Yeah, thank you for having me, as I already said. So I'm Robert from Fraunhofer Focus, the Institute of Open Communication Systems. And what we are usually doing is mobility applications with communication and digitalization, and obviously also the transmission of data. And we are doing this together with the Technical University of Berlin, the DCIT. So we are also here located in Berlin, on the other side of the city, I would like to say, in the north west. And what we do is implementing those applications, but we also have a big part in simulating them. And having this said, I will go to the introduction, what our view is on those applications. So from our perspective, the mobility systems have really the different participants, foremost, obviously, the vehicles, but also the other participants, unmotorized, like pedestrians or bicycles, or even static entities like traffic lights, roadside units, and the like. And especially when you are going in the direction with this communication part and the digitalization, we have a lot of work also to do with servers, formally also with direct communication between vehicles, which is a little bit on the downside branch, because the current networks, centralized networks, are quite mature already for many use cases. Yeah, and our use cases for a long time only had those communication aspects, but now what we want to also introduce is that the entities, they gonna have an object detection or perception, and they're gonna detect their environment and share those information. The usual day one applications with the communication were mainly with the internal state. And yeah, those applications, when we want to put this into simulation, we can make use a lot of from the features of the mature simulators like SUMO. I will come to this later on. But we also have to do to model a little bit on top. But first, I want to introduce a specific application we are currently quite interested in, which should underline this in a little bit more detail. Is as I said, the applications based on object detection is what we currently implemented with real-world data, and we are also testing this in the real world. You can see here a vehicle which is equipped with a smartphone camera. We also implemented it with an onboard unit of the vehicle directly together with this Daimler Center. And what we can do there is, with an AI-based approach, we have a perception of our surrounding, and we can detect objects. It's currently mostly trained on labels like vehicles, but we also go in a direction or develop this to train it with traffic lights, with traffic signs, and also with those roadside roadwork zone traffic signs, to really get a big holistic picture, local picture of the surrounding. And what and this implementation is usually done, as I said, with real-world data, or even with partially with submicroscopic simulations, or quite detailed simulation of the surroundings. But the question is, when we want to also employ SUMO and larger scale simulation, which questions or research questions we can answer. And here, for example, is an improved traffic state estimation. So our research question here is if we could improve the data, so what is it, traffic state estimation, not only using floating car data like the position, velocity, or heading, or something like this, but enrich this data with the vehicles in the surrounding, maybe to detect the traffic jam, the traffic lights with their phases, the traffic signs, obviously, or even what I did not say up to now is the number of lanes which are currently able to be driven on. And so, yeah, and we have some questions. If our application, which does our object detection, is already sufficient, or do we need some improvements? Therefore, for instance, we could also ask how big has such a perception range has to be? Is it only the vehicle in front of me, or is it quite bigger picture, or even all vehicles in our surroundings, so a 360 degree perception, which might then require additional cameras, for example, or even LiDAR setups. Yeah, and this is our application, and we to analyze this in simulation, we are based on our framework Eclipse MOSAIC. Robert already told us, and I just want to introduce our general slide, what we are doing there. Not everybody knows it. So as I already said, we actually base a lot on SUMO features, but we enriched it to a certain extent and do not only use SUMO. And therefore, Eclipse MOSAIC is as a core simulation framework, also dedicated to the session here, and it couples different simulators from different fields, and it manages all the synchronization of the different simulators in time, and therefore it has generates a more holistic picture that we can use the traffic pattern from the traffic simulation or the vehicle simulation. We can even exchange it quite easily, the different simulators. So we have there our own development, which is the FabMax, and currently we also approached using Kala for a submicroscopic simulation, which is also quite, let's say, dynamic project with a good community for development. And most of the part we analyzed those applications is positioned in the application simulator, and there we can put different applications, so even multiple applications on one vehicle, but also we can really nicely equip different vehicles in this simulated scenarios. And communication comes on different communication links, with cellular communication, with talk communication in the direct field. And for our perception module I present here in this talk, I want to go more in the relation between the application simulator, because there the application is located, and the traffic vehicle simulators. And this is how it looks. So Eclipse MOSAIC runtime environment is still in the middle. On the left, we have the application and traffic simulators doing all the vehicle movements, and they can in turn get commands to control the traffic, Tracy, from the application simulator. And the application simulator hosts then the different vehicles. So basically, it's like a digital twin of the of everything what happens in the traffic simulation, and it has, let's say, a global components which is the unit simulator, and the global map for routing, and the novel perception index. So I'll present them later. And it has all these modules which are encapsulated in an operating system for each individual vehicles. And if you develop one application, you have to implement a unified API. And here this example shows, for instance, how we envision this new perception module. So this is also part there of the operating system. You just can enable it, and yeah, you have, with this application, you have to implement certain interfaces, and then you can also perceive objects in your environment. Our first implementation is mainly based on vehicles, perceiving vehicles, but in general, we still open to extend this. Okay, going a little bit more into detail what global perception index and vehicle-specific perception module do. Yeah, basically it's the same, a similar picture as on the last slide, and I do not want to dig too much in the details. So we also have written a lot of this in our paper. I just want to say that the global perception index and the whole simulator, application simulator, follows different implementations. So a trivial approach where we only have a loop over all vehicles, so where we get updates from. Obviously, when we have a lot of vehicles, we can perceive, and a lot of vehicles, they can perceive their own and perceive their environment. You have basically two loops, and this can grow quite fast. And therefore, we have some advanced approaches, the tree-based and the grid-based approach. And the perception module then is used to filter the individual objects from in the field of view, because the global perception index and those searches, the quadri and the grid-based search, they are more like coarse search, and the perception module is the fine search. So we are now here at the SUMO conference, and so we also did evaluate which two-features we can for a specific SUMO setup use and improve the solution. And therefore we have this solution 2. So solution 1 was that we subscribe data on all vehicles, build up our perception index, and use the perception module. But SUMO also provides the context subscription features, where you can directly retrieve surrounding vehicles in the field of view directly from SUMO. And because SUMO generally for the at least for the car following model, it needs its leader and so on, and SUMO also has access to this field of view and can provide the data. And this looks like this. Even with our with two approaches now, that the novel Eclipse SUMO approach, we can also achieve this. So we have implemented a Tracy as well as a novel Eclipse SUMO enhancement, where we can gather all this data in our co-simulation environment in the application simulator and make use of it. So I'm a little bit long already. So and I want to also come to an end with an evaluation. I do not want to go too much in the scenario here, even though it seems to be quite interesting also. but it's still a little bit work in progress. We, as I said, we want to evaluate our application in a large-scale scenario, and there we selected the Berlin scenario. Yeah, I also was in the tapas workshop, and I'm also quite interested in those approaches. So what we did with our scenario, we based on MATSIM, macroscopic open Berlin scenario with all these activities, and we try to integrate them in SUMO and recalibrated the traffic, as we already heard, with reducing the teleports, modeling, and so on. And for the paper here and the work here, we did 2 evaluations on this scenario, and also on a smaller part with only a part with the Charlottenburg scenario. And this is what I present in the next slides. It's the performance of our spatial index, basically the quadri approach and the grid approach, because the trivial was actually too slow. And we also...
Robert, you are already 1 minute over a time. Maybe you should try to cut it a bit shorter to leave some space for questions afterwards. Thank you.
Yeah, and this is basically what I want to finish with, is that our setup works, let's say. The grid is slightly faster compared to the quadri, and we have a quite, let's say, linear performance or linear complexity. This is quite good, because with the high number of vehicles, we still can simulate this perception in a sufficient time. And what's maybe more interesting here for you also is this evaluation of Tracy versus Eclipse SUMO, and then we can say that Eclipse SUMO is really faster than Tracy. And we are really happy to use this also in the future. And what we also saw as a side effect, that our perception with the MOSAIC perception with our quadri was a little bit faster than when we use the context subscriptions, especially in higher equipment rates. And that's basically it. Answering your first question, is it available? Yes, it is on GitHub, also in our new release. So I presented this perception module, as I said, providing this unified API, having the different couplings to SUMO, and having this said, Eclipse SUMO is really better than Tracy. And I already had a little bit of an outlook for future work to finalize basically our scenario and really evaluate our applications in this large scale. Thank you for having me.